Hello friends, so here we have two problems. In this one came in 2006 and other one in 2007 mains. I think first we'll take up second one because that is an easier problem, and what that says is a particle is projected at 60 degrees to the horizontal with a kinetic energy K, and we have to find the kinetic energy at the highest point. Now first we'll draw the projectile motion. So when we throw any object at an angle theta, it will have two velocity components. One is the horizontal velocity component and the other one is vertical velocity component. So here I am drawing this which says that for a velocity v, the horizontal velocity will be v cos theta and vertical velocity will be v sin theta. Theta in this case happens to be 60 degree. And what we observe is that the particle's horizontal velocity does not change. Reason being, there is no force on the horizontal movement, whether opposing it or supporting it. While vertical velocity has gravitational force acting on it, which is always in the downward direction. Now, as the path progresses, the vertical velocity keeps declining to the point that it becomes 0. So the Vy becomes 0 and Vx remains V cos theta because there is no force opposing it. And thus, and later on it grows and vertical velocity also starts growing as it goes under free fall. Now having said that, V cos theta will be V cos 60 in this case, and cos 60 is 1 by 2. So on top of the flight, velocity of the particle would be V cos theta, that is V cos 60, that is 1 by 2. And when the object was thrown from ground, it has velocity V and a kinetic energy K, which is equivalent to half mv square. So on top what we are observing is that we have a velocity of v by 2. So the kinetic energy on top of the flight or k dash will be half mv by 2 whole square, which is 1 by 2 into m into v square by 4, which is 1 by 8 mv square, which is 1/4 of k. So k by 4 is the right option for this question. Thank you, and now we'll proceed to problem 1. In problem 1, what we are seeing is a particle located at x is equal to 0 at time t is equal to 0 starts moving along with the positive x direction with a velocity v that varies as v is equal to alpha root x. Alpha is some constant, so we'll write v is equal to alpha root x, and we know that velocity is change in displacement, so we can write v as dx by dt because there is no movement in y direction. Particle is moving along positive x direction. So this is dx by dt is equal to alpha root x. Now if we take x on the side of dx, what we observe is we get 1 by root x dx is equal to dt. And if we integrate both sides, what we see is we are talking about integration of x to power minus 1 by 2. So xn dx is xn plus 1 divided by n plus 1. So that is x minus 1 by 2 plus 1, which is x 1 by 2 divided by 1 by 2. And the 2 sort of comes up because it's in the denominator. So it becomes 2 root x dx is equal to t. plus c, which is some constant. Now if we square up both sides, what we see is x square is equal to t by 2 whole square plus another constant c1, which is equal to t square by 4 plus c2, which is another constant. Now we are given that x is equal to 0 at time t is equal to 0. So we put those values and we get x is equal to t square by 4. So that means position is changing in the square of time. And in this case, option A, t square is the right answer, because we don't have to really get into calculating position at a particular time or something. All we have to establish is what is the relationship of x with t. So that sums up both the problems, and thank you. अरे 6.10 से फिर दोबारा शुरू हो गई, ये क्या बात?